Hello. Today I'm going to spend some time talking about using Vault Radar for secret scanning. For that to fully make sense, I think we need to take a quick second to just talk about what is a secret and why are we scanning for them and what's the kind of point of doing the secret discovery to begin with. And then from there we'll flow into what radar is and how it actually works. And so with that, let's just go ahead and jump right in. So when we talk about what is a secret, the way I like to define it is a secret is really anything that can be used to give you an ability to authenticate against a system or to be authorized to perform an action. So great examples of secrets end up being, kind of the classics that you would expect. Things like a username and password, for example, right? So if I have a username and password, I can use that to log in and authenticate against the system. That might let me do all sorts of things, right? Other examples of that might be a certificate, right? So if I have, PKI certs, TLS certificates, great example of it. Typically, you can't log into a system necessarily with a certificate, but you can use it to authorize yourself to perform different actions. I could pretend to be a web service that I'm not. I could pretend to be a database that I'm not. And in that sense, be authorized in a way that is inappropriate, right? So this is a good example. I might have things like API tokens, right? So if I have an API token, it might let me authenticate and make requests against the system. So all of these become good examples of things that I want to consider secret. And the reason they're super sensitive and they're secret information is if they were leaked to an adversary, they could potentially use that to get authorized into systems, to take data they shouldn't have access to get, to perform actions they shouldn't be allowed to perform. And so these can be particularly damaging. In contrast to something that's secret is what I might consider sensitive. So sensitive data is something I obviously want to protect. It's important, but it's not quite enabling me to authenticate against the system or authorize against the system. So an example of this might be, I might have customer PII data, right? So I might have my customer's name, address, email, etc. That's obviously sensitive. I don't want to lose that data, but you can't log into my database with a customer's name and email, right? So that becomes a category of sensitive data. You might put a whole bunch of different things in here. So I might have credit card numbers, right? Those are obviously sensitive. I don't want to lose them. A customer might consider them fairly secret because you could authorize a transaction with them. But you can't access, let's say, internal infrastructure data with them, right? Social security number is another good example, right? So all of these would fall into things that are sensitive information. And so the differences between these tends to be in the volume of the data of it, as well as where they end up getting located. Almost always sensitive data ends up being the much bigger data set, right? Good example might be, I might have one username and password to log into a database, but I might have millions of records in that database, right? So in that sense, the sensitive data is orders and orders of magnitude bigger volume than typically what you see from secrets, right? So your approach to managing these things tends to be different. With secrets, it tends to be a small group of people and systems need access to them, right? My web app needs a database credential to log in. Maybe my human users need access to go debug something with the database, right? So a small group needs access to those things, right? Versus these tend to be stored and encrypted at much higher volume, right? So one of the actually key things that we're missing here is actually I'd put keys, right? Specifically encryption keys, because those often get used to protect sensitive data. So I might have a secret, an encryption key. That one key might protect millions of records because it's encrypting that data, right? So now when we think about where these things end up living, they end up in different places. Sensitive data, typically by definition, you have a lot of it, and so it lives in production runtime systems like databases for the most part, right? Secrets, on the other hand, have a way of finding their way everywhere because there's not that many of them. They're small, and you end up needing them to authenticate to different systems or to perform privileged operations. So for example, I'm sure we've all seen it in a number of different places, right? For the most common being probably configuration files, right? So if you think config files for an application might include the database username and password. Oftentimes it ends up in source code of the app, right? We've probably all seen the hard-coded certificate, the hard-coded username password, maybe hard-coded encryption keys or API tokens, where someone's just pasted them in and encoded it as a static variable value in the source code of the application itself, right? But I think more than that, because these are often used by humans to get access to systems, they can end up in a whole bunch of human collaboration systems as well. So for example, Slack and Teams ends up being a very common place where you might find these, right? Or you might be, pasting it into, a JIRA ticket because you're filing a ticket. You're saying, here's my steps to reproduce this problem, and here's this little snippet that talks to the database. And by the way, the database username and password is hard-coded in that. And then so on and so forth, right? It might be in your wiki pages because you have a run book that says how to restart the database if something goes wrong, and you have the SSH key as part of it. So you end up with the credentials in a whole bunch of places. Ultimately, our view is that most of the time secrets shouldn't live in any of these places. They should really only live in systems designed to hold secrets, systems like Vault, right? A system like Vault is designed for secrets because it's always encrypting the secrets at rest. It has tight access control around it. It has tight audit logging around who accessed a secret and when. And so it's built around the idea that all the information stored inside a vault is a secret, right? Versus you think about something like source code. Generally speaking, lots of people in an organization have access to the repos, right? It doesn't really audit who's looked at the source code, right? Because it's happening so frequently. People are checking out that repo. It's on their laptop, right? The source ends up decentralized. It's all over the place, right? Same thing with something like Slack, right? You're not auditing who's read every single message. You're sort of pasting a message. Lots of people might read it, might not read it, right? It's sort of an ephemeral chat environment in that sense. So these are not systems that are really designed around the idea that you're storing and managing secret values, right? Unlike a system like Vault. And so oftentimes what you end up happening is people might start with the best intent of using systems like Vault, and over time credentials end up in all of these different systems. So when we think about, introducing a new product, Vault Radar comes out of an acquisition that we made at HashiCorp, a company formerly called Blue Bracket. And the idea with Radar is that it acts effectively as a early warning radar for those types of leaks, right? Ultimately, credentials that end up in these types of systems are more likely to be compromised, right? Because they're not systems designed to manage secrets. So we want to connect Radar into all of these different sources, basically, and it acts as a continuous scanning mechanism to look for any credentials that are embedded in those environments, right? So if someone accidentally pastes it into their source code, we can detect that, someone checked this into Git. There's a database password that's been checked in, or great, Armand pasted a private certificate into a Slack message. We can see it there, or it might be in my Confluence wiki, things like that. So we want to be able to scan all of those in addition to being able to scan systems like Vault, because what it gives us then is a full inventory of all of our secrets, right? So what we want to really do is be able to do the discovery. And so once we've discovered it, now I have an inventory that can tell me, great, where are all my credentials? Some of them are obviously in Vault, which is good. It's where they should be. And then some of them are obviously out of Vault, right? These are sort of, unmanaged secrets, right? They're, a secret that's in Slack or a secret that's in GitHub, right? And so these tend to be the ones that we're worried about because these represent risk, right? These are the ones that are most likely to be compromised or, cause someone to be able to get inappropriate access to a system, because those are the kind of systems that don't impose least privilege controls and auditing and all that kind of good stuff. So these are the ones that we probably want to alert on. Most of the time, you're going to want to send a security team alert or notify your developer and say, hey, Armand, you just pasted a secret in Slack. You should probably delete that and not put it in Slack. And even better would be you should rotate that credential, right? You should assume that credential has been compromised, right? So the first piece of Vault is really about this sort of detection piece, right? It's about connecting into all of these different layers where we might have a secret accidentally or on purpose stored so that we can do the discovery and build that inventory. And there's a subset of systems that we're fine with, and there's a subset of systems that we're not fine with. Those are the ones that we want to sort of remediate and do something about. And so when we want to do that remediation, obviously we're going to integrate with systems like Vault so that we can import those secrets and have a place to securely manage them. Now, I think one of the challenges is as we're doing this sort of discovery across all these things, you can often end up with false positives, right? You can have things that maybe look like a credential, or maybe it is a credential, but it's hard to tell, is this a high value, low value credential? So you don't necessarily want to create a whole lot of noise in terms of generating a whole bunch of signal of, hey, this thing is a secret, somebody has to go deal with it. And someone looks at it and it's like, no, they just hard-coded, test, for the purpose of having a variable there, but that's like not really an actual secret. And then the system gets noisy and people then ignore it, right? Because it becomes the boy who cried wolf. So one of the important pieces is when we think about this is two important things. One is, can we do invalidation? Basically, can we prove that a credential actually isn't real, right? So a great example of this might be someone hard codes within their source code and says, great, I have, my AWS IAM credential, and it's, equal to blah, blah, blah. And so we can look at that and say, okay, well, great, it looks like an Amazon key. But then can we actually invalidate it by going and talking to AWS and basically querying and being like, is this a valid key, right? And if Amazon says, no, it's not an actual valid key, then great, we can invalidate that and say, yeah, we saw this thing in the source code, but someone just, pasted XYZ in there just to have a placeholder. It's not an actual, risk. We don't need to alert on it and create a bunch of noise, right? So this becomes an important filter on that, right? If Amazon says yes, then we know, okay, this actually is valid and, potentially a high value key. Okay, so we're going to bump that up in the priority of like what you need to go look at to actually remediate, right? So then that becomes the second piece of this is really a ranking exercise, right? And so you might say, okay, credentials might fall into sort of, ultimately sort of a high, medium, low category of importance, right? High category probably is a key that is active, like you have an Amazon key, it's valid, we know it's valid, and it's an exposed system. That is a high vulnerability thing that you want to go deal with, right? Because great, if someone got access to your Amazon key and now they can go make arbitrary changes in the environment, that's a bad thing. Then you might have things that are maybe medium risk, right? So what's a medium risk might look like? For example, could be a system like, Vault, for example, can generate a dynamic secret. So if we have a dynamic secret, these are secrets that only live for a short period of time and then are automatically destroyed. So you might just define a secret that great, at time 0 gets created. Maybe it lives for 30 days at a time. Usually the client sometime between time 0 and 30 days is going to request a new credential, right? So we might start and say, hey, the username and password is X and Y. That's valid for 30 days. Day 15, they ask for a new credential. They switch to A and B, so on and so forth. So we're always sort of moving from one credential to the new one, and then eventually Vault comes behind us and deletes the old one, right? So now what happens if we come by and we scan and we detect, hey, we see X and Y has been pasted into a JIRA ticket, but we're sort of after that 30 days, right? We know that that secret X and Y is no longer valid. It's been destroyed, but we know that at some point it was valid, right? That might be an example of something that's medium severity, right? Because you have actual credentials being leaked. Maybe this is being done in an automated way, right? Like, that was, it's an application that's logging it out or something. And so you want to go look at it and say, these are real credentials. We know they were valid. They're not anymore, so it's a lower priority than high. But it could be a cause of something, systemic. Maybe they actually leaked A and B as well, and A and B still are valid. So we want to be able to look at things like that where they were known valid and we knew that they were valid credentials, but maybe not as critical as something that's currently live and we know about it, right? And then you might have low priority things where it's like we can't tell is it valid or not valid, and we don't know if we've seen it anywhere else. That's a good sign, right? Another good example of a high value is if I find a key that's sitting in my wiki and it matches a key that I know is inside a vault, right? That's an example of a key that, great, it's a signature match for an existing secret that we're putting into a managed system. That's probably a high value key that shouldn't be sitting in sort of an unmanaged environment, right? So when we think about these two, this becomes really about how do you make the signal to noise ratio much better, right? We want to focus on actively invalidating credentials and then actively ranking them based on what we know about secrets that are managed versus unmanaged, expired versus unexpired, and using that to present the highest value to the users in terms of these are the secrets to go focus on remediating, right? Now you can think about running this sort of process once to do the discovery, you can find that, and then go fix all the issues. Unfortunately, the problem is, we're never perfectly done with this because both our humans and applications are imperfect, right? Even if we said we got down to 0% on the outside, 100% of things are sort of in Vault, almost invariably what we've seen over and over is, well, great, a developer logs into Vault, they pull out that secret, and then they inadvertently put it back into a wiki, or they hard-code it into the source code because they don't want to go deal with it, or they weren't thinking about it, or they're just pasting it in for a test environment, and they wanted to quickly run some test, but now they've exposed that credential. And so I think from a human side, these credentials end up being continuously sort of re-leaked, right? So it's a continuous process. It's not just we should do a one-time scan. We need to continue to re-inventory as new Slack messages are posted, new JIRA tickets are created, et cetera. But I think equally important is on the application side of the house, right? An application will oftentimes read credentials out of Vault to connect to a database or whatever, But then the application, has an error, has something go wrong, and the first thing it does is log it out to, the log store. So now we're going to ship it out to Splunk, and we have, an Amazon key that was part of the log message that was sent out there. So once again, how do we detect that thing? And then we potentially need to remediate it by rotating it or fixing the application logic so that it doesn't log out, secret information when there's an error message or a particular transaction fails or whatever is the case. So when we think about this, it's sort of a continuous process. Ideally, the goal is you get to 100%, here and 0%, outside. I think the reality is going to end up being something more asymptotic, right? You can get close, but there's always going to be that sort of blurry line where it's either we have, users who are, well-intentioned and well-meaning, but, maybe not always doing the right thing. And then similarly, we have applications, right, who will be leaking these credentials. So the goal is, can we at least get to the low part of this curve and then shorten the amount of time that it takes us to detect the credential, ideally then remediate it, right, rotate it, revoke it, whatever needs to be done, and then properly handle it, put it in a vault, make sure it's not being logged out, things like that. And so that becomes the goal, is can we have a tighter time to detect and a tighter to remediate versus an attacker or an adversary who might be in network looking for those credentials, trying to escalate their set of privileges and capabilities, right? So that's really at a high level the goal of Radar and how it works. Really at its heart, it's delivered as sort of a managed cloud service. You can connect it into various systems so that it can do both one-time and continuous scanning. And then it can use a mix of different techniques to sort of prioritize and then notify through webhooks and emails and other mechanisms. So you have a dashboard say, here's where I need to go focus on, here's the top priority secrets, and then ultimately work to get to the bottom part of this curve. I hope that was helpful just to give an overview at a high level of what is secret scanning, what's the importance of it, and how does Vault Radar solve some of those challenges.